So in continuation to the example that we have discussed in the previous video, we have generated the matrix in the row echelon form, and then we have formulated the equation like this from the obtained matrix, and we have solved the value for the right hand side variable, that is a is equal to -1. So in order to get the general solution from the given set of linear equations, first step is you need to find the particular solution. So in order to find the particular solution, first step is like we want to identify the non-pivot columns and set those non-pivot columns to 0. This non-pivot columns will be representing some variables. So from the example, from the solution, we can say that this first column will be representing for the variable x1, second column x2, third column x3, fourth column is like x4, fifth column x5. So pivot pivot is there in which all columns? X1, that is first column, third column, and fourth column. Okay, so the variable x1, x3 and x4, they are the basic variables, and the non-pivot columns represent the variables x2 and x5. So first step is like you need to, in order to find the particular solution, identify the non-pivot columns and set the value for those variables to 0. So here x2 and x5 will be set as 0. Okay, x2 and x5 will be set as 0. Then apply the values to those equation that is generated over here. You will be getting the values for the variables x4, x3 and x1. How? First you need to substitute the value of x5 over here. So x5 is 0. Then x4 value will be equal to 1. Then substitute the value of x4 and x5 over the on the equation 2. Then you will be getting the value of x3 as x3 is equal to -1. Okay, x4 1 and x5 will be equal to 0. Substituting it, and when you get the value, what is the value you will be getting? x3 will be equal to -1. Then afterwards in equation 1 you need to substitute the values for all the variables x2, x3, x4 and x5, those variables that you got, and you will be getting the value of x1 as 2. You can check and see whether you are getting this result. So once you got the value, once you get the values for this x1 to x5 variables, you can form a vector like this: 2, 0, -1, 1 and 0. This is the solution, that is a particular solution for Ax is equal to B. Now second step is you need to find all solutions to Ax is equal to 0. Okay, so for that we are making use of a concept, that is a null space concept. We are making use of a null space concept in which it captures all the possible linear combinations of the element that produces the value as 0. So here we need to identify the free variables. As we have seen in the previous matrix, free variables are x2 and x5. These are the free variables. You need to assign some value for this x2 and x5. So in order to since we are making use of this null space concept, we are using identity matrix in order to represent this null matrix. And as we all know, identity matrix will be represented using zeros and ones. So we can give values of x2 and x5 as 0 and 1. So there will be two cases: x2 value when it is given as 1, x5 equal to 0, and the second case will be like when the value of x2 is given as 0 and x5 is taken as 1. So the equation also you need to redefine it as of the form ax is equal to 0. So the previous equation only you will be taking, only difference is the right hand side will be made as 0. Okay, the previous equation, that is after row echelon form, after reducing the matrix to row echelon form, you will be getting one set of linear equations. The same set of linear equation you will be considering here also, but only difference is the right hand side will be made as 0 in order to get the solution to ax is equal to 0. And then apply the values x2 equal to 1 and x5 equal to 0. So x5 equal to 0, when you apply in this equation, you will be getting the value of x4, and what is the value you will be getting? X4 is equal to, x5 value is 0, so x4 also will be equal to 0. So this is equation 1. Okay, then in second equation apply the value for x4 and x5, you will be getting the value of x3 as 0. Then apply the value for x2, x3, x4 and x5. In equation 1 you will be getting the value of x1 as 2. So you got the values for all the variables. You will be getting the vector like this. Okay, so here you will be getting a vector, and this vector, when you apply any scalar or any when you multiply with any scalar quantity, the resulting vector also will be a solution to the equation or to the system of linear equation, that is ax is equal to 0. Okay, so for that lambda 1 and this vector 2 1 0 0 0 will be a solution that is being generated. This is with the first case, and second case also similarly you will be getting the solution for the variables x1, x2, x1, x3 and x4, where you will be taking the values of x2 and x5 as 0 and 1 respectively. So the resulting solution will be obtained like this. Here also you will be generating one vector having the values 2, 0, minus 1, 2 and 1. And when you apply any, when you multiply with any scalar quantity lambda 2, the resulting value also will be a solution to the system of linear equation, that is ax is equal to 0. Okay, so this, now you have obtained all solution to ax is equal to 0. Next final step is like you need to combine all these solutions. So the particular solution is this solution, and these two are the all solutions to the ax is equal to 0 case. When you combine these two solutions, you will be getting the general solution. So how you will be writing it? Set of all possible solutions is x element R5, x is equal to 2 0 minus 1 1. That is the solution obtained from first step, and then the solution obtained plus lambda 1 the vector, lambda 2 the vector, where lambda 1 and lambda 2 the element R. That is the real numbers. So here R5 means that how many number of variables that is used in this system of linear equations. Here we have made use of 5 variables starting x1 to x5. So that's why here it is given as R5. Okay, so this is the general solution. So in next this is the same example that we have considered. So what we have done, we have converted the matrix into a, or converted the linear equation to a matrix form, and that matrix is reduced to a raw echelon form, and then made the transformations. Transformations were made in order to convert the matrix to row echelon form, and then you found the particular solution as well as the all solutions to system of linear equation Ax is equal to 0. And combining both the solutions, you will be getting the general solution. So next method is like considering the reduced row echelon form. So you need to understand the difference between row echelon form and the reduced row echelon form. So row echelon form is like it will be meeting these requirements. That is, first number in the row will be 1, and it is not necessary that the leading coefficient is 1. It can be any number. So it is preferred to have 1. It can be any other number also, but in order to solve the equation, it is preferred to have the leading coefficient value as 1. And every leading one is to the right of the one above it. That is, in order to choose the pivot. What is the condition? Every pivot will be right to the one that is obtained in the above row. Any non-zero rows are always above the rows with all zeros. So rows with all zeros, it will be coming towards the bottom of the matrix, and rows with the non-zero values will be coming on the top. So these are conditions that will be satisfied for any row echelon form. So here some examples are given for the row echelon form. Similarly, see here row echelon form, these are the pivot that is being considered. But for solution, what you need to do, you need to convert this 5 and 2 to 1. Some way you need to convert the value of 2 and 5 to 1 so that the solution can be made easier. And not row echelon form examples are also given here, like all zero row, it comes in the middle of the matrix. So you need to transfer to the end of the matrix, that is bottom of the matrix, it need to be transferred. Like that some conditions need to be done. And here we need to make it as 1. Okay, we need to make it as 1 so that a solution can be done in a proper way. Now next is the case with the reduced row echelon form. In this reduced row echelon form, it should be in a row echelon form. That is the first case that need to be satisfied for any matrix to be in reduced row echelon form. And its basic columns are the vectors of the standard basis, which means that vectors having only one entry equal to 1 and all other entries will be equal to 0. That is, if you are considering any column with the pivot 1, then all the other entries for that column will be obtained as 0. It should be 0. So in this case here, first column pivot is here 1. Second column pivot is located over here. So when you consider these two pivots, all the other entries, they are 0. So if such a case occurred, means we can say that the matrix is in row echelon form. Here also this is a pivot. Both the other entry forming the column, it is 0. So it is in reduced row echelon form. So here some examples related to reduced row echelon form is given. Identity matrix, it can be treated as a reduced row echelon form. So reduced row echelon form, if and only if it is in row echelon form, all its pivots are equal to 1 and the pivots are only non-zero entries of the basic columns. Non-zero entries of the basic columns. So with respect to this, we will be able to convert the rows to reduced row echelon form also. Similar to what we have done in the previous example, some list of operations will be performed in the rows to convert it into row echelon form. Okay, so here this is not in a row echelon form. So in order to convert it into row, that is, you need to make it as 0. Some operations will be performed in the rows in order to make this 9 by 5 as 0. Okay. So next we can see an example based on this row echelon form, reduced row echelon form, whether the matrix is reduced 1 and how solution can be found that we can